Okay, here is a tips and shortcuts video. Okay. It's video number 16, part 105, and in this video we will discuss a divisibility by 4 and 8. Okay, and I have split the video in 5 parts. This is the first part. Okay. Let's continue. We have split that video in some sections. Its first section is divisibility by 4 and by 8. Next we'll discuss converting between kilos and pounds. Then we'll look at converting between miles and kilometers, converting between Celsius and Fahrenheit. Okay. Now let's go look at divisibility by 4. Okay, I know we have discussed that before, and I just want to redo it in this video here. Okay. So what's divisibility? A number is divisible by another number if a remainder is 0. So we are looking for a remainder of 0. Okay. So here's the basic problem setup for the division. We divide a dividend by divisor and we get a quotient and a remainder. So in division we divide a dividend by divisor and the answer is quotient with the remainder at the end. That's from Glover's book. Okay. Let's continue. Do you recall how to compute remainder? We do the repeatedly subtract multiples of the divisor from dividend until a number smaller than divisor remains, and that smaller number is the nominal remainder. We also have used altered remainders usually in a division problem. So this is the remainder. Remainder is usually smaller than divisor. At least nominal remainder is smaller than. Okay. So same problem again. Okay, and we have, you can refer to, we had done that before, and that divisibility by remainders discusses the issues we are talking here. Okay? So clearly to determine divisibility, we need to determine the remainder and see if it is 0 or divisible by the divisor. Let's continue here. A nominal remainder is 0 or a altered remainder is divisible by 0. Our mantra is short and sweet, one line, mental solution. So we need to make determining that remainder easy. So we have to find our remainder and find out easily and do so without dividing. Let us continue here. Still, we continue with same section here. Okay. In our case, divisor is 4. We first subtract multiples of 100. You know what 100 is? It's 25 times 4. Then multiples of 20, which is equal to 5 times 4. And check to see if the remainder is either divisible by 4, and to be that it has to be either 0, 4, 8, 12 or 16. Okay. Okay. So when we subtract multiple 100, what are we doing? We are finding a remainder of dividing by 100. Okay, when we subtract all the 100 we can, then we have a number left which is less than 100, and that's the remainder of dividing by 100. Okay, do you recall doing that before? Have we done that before? Okay, we sure have done that in the divisions. When we were doing divisions by Nicola method, by transpose and apply, and also by straight division, we were dividing by 100. Okay, or a base number. Okay? We would have two-step divisions. One was, first step was dividing by base number, and 100 is the next page here. Okay, let's continue here. So example will do that to find yeah, to see where we did the division by 100 before. Here's an example, Nicola method, 75392 by 97. Note that 97 is equal to 100 minus 3. Okay? So, and the 100 is 100 times 1. So nuclear method of division, and that is described in this video here. And we set a problem like that: 75392, and the efficiency is 3, divisor is 1. It's right here. For dividing by 100, we draw a line to the left of 2 digits. Okay, and we call that, if we were to divide by 100, this is the remainder and this is the quotient. And also when we are decimalizing, when we divide by 100, this is where decimal would go. We draw this line to say that this is the remainder section and this is the quotient section. Okay, let's continue. So to divide by 100, we draw a line to the left of 2 digits, and the digits on the right. Okay. Now, how do you find remainder from division by 100? So this is we draw a line, and then digits on the right are the remainder. We draw a line to the left of rightmost 2 digits. The 2 digits on the right are the desired remainder, which would be less than 100. How would you find remainder from division by 20? Okay, how would you do that? First, 100 was a base number, so straightforward. We draw a line to the left of 2 digits. There are 2 zeros in 100. So okay. So now how about 20, where we have to find the remainder of division by 20. Same two-step method we have used all the time. We use same two-step method we have been using all the times. So first divide by 2 and then by 2. First by 10 and then. So, okay. So for take example, this is what we had so far. Here's my example. 451436. Is that divisible by 4? First is division by 100. We draw a line. We got 36 on the right and 4514 to the left. And this is the remainder. This is the quotient. This is the line that says we can divide. Okay. So, and we are looking for remainder only. We'll keep the remainder 36. Okay? The next step, determine the remainder from, now we 36 remainder, we would subject that to successive division. Next division is by 20. Okay? So how we said that we would do that by same two-step method. Okay, let's continue here. So 20 is 2 times 10. First by divide by 10 and then by 2. Okay? So same thing here. So we're going to, we just did divide by 10. 6 is the initial remainder here, and 3 is the quotient when we divide by 10. Now we would divide by 2 again. When you divide 3 by 2, remainder is 1, and the final remainder is 16. 1 remainder from 3 divided by 2, and which is to the left of the 6. 1 and a 6 make it 16. 16 is the remainder when we divide by 36. So 3 divided by 2 is 1, and remainder is 1. Thus remainder is 36 divided by 20, remainder is 16. And 16 is in this, first 16 is divisible by 4, so is 451436. 16 is also in this list of divisible numbers, 0, 4, 8, 12, 16. This is the multiplication table for 4. These are numbers in, this one is in 4 times 1, 4 times 2, 4 times 3, and 4 times 4. And this 0 here is 4 times 0. And remainder of 0 means it's divisible, and so is this remainder is also says number divisible by 4. So 451436 is divisible by. Okay, now another example is 986524 divisible by 4. So we went to lots of work to find out it was number was divisible. Now we would go use all the shortcuts we can. Okay? So first is remainder, we split number like that, 986524. Okay, then draw a line. Okay, and then we cross this thing we don't need. This is a quotient we don't need. We cross that out, toss that out, and 24 is the remainder. Okay, next step, we're going to divide by 20. Okay, and 24 is what we're looking for. So we say we first divide by 10, so we get in 4 is the remainder we know, and 2 is on the left. Okay, then let's take out all the 2's from here, so 0 left. So 4 is the final remainder here. So 4 is in this list of 0, 4, 8, 12, 16. 4 is divisible by 4. So 9, 8, 6, 5, 2, 4 is divisible by 4. What we did? First we took the rightmost 2 digits and tossed out the ones on the left. That was a quotient, and this is the remainder. This line lets me divide a number by 100. Then 24 left. We two-step method again. We divide by 10 here. Draw this line, and then take out all the 2's we can from the left. So there is 0 left here. Final remainder is 4 and a 0 to the left. That's 4. So 4 is divisible by 4 and also is in this list here. So 9, 8, 6, 5, 2, 4 is divisible by 4. Let's continue. An example is 5, 6, 6, 8, 4, 6 divisible by 4. Let's continue here. First we find our remainder from division by 100. Okay, so 46 is remainder, 5, 6, 6, 8 is a quotient. And we'll toss out the quotient. 46 left, we'll subject this 46 to further division by 20. Remainder from 46 divided by 20 is, we write down 4 and 6, and then we first is we divide by 10, then 6 is the initial remainder, and we might get some more remainder from left. Then 4 is on the left. Okay, we divide 4 by 2, and first nothing left. Okay, if you divide 4 by 2, the left is 0. Okay, so we get then 6 left, and remainder of 6 is not in. So final remainder is 6 here. 6 is not in this list of 6 is not divisible by 4, and neither is 6 is not in this list either. So this number 5, 6, 6, 8, 4, 6 is not divisible by 4. Let's continue here. Okay, 5, 6, 6, 8, 4, 6 is not divisible by 4. Now try to extend that to divisibility by 8. Okay, for divisibility by 8, we have to quickly determine a remainder of division by 8. Okay, so for that, what we do is, for that, the steps are: find the remainder from division by 1000. Okay, 1000 is 8 times 125. Then divide the remainder further by 200. 200 we got from 1000 divided by 5, and 2000 is 8 times 25. Okay, then divide further by 40, the remainder further by 40, which is equal to 200 times 5, and 40 is 5 times 8. Okay? Check to see if the remainder is in this list of from the multiplication table: 0, 8, 16, 24, 32. If the remainder is in this set, then the given number is divisible by 8. Quick example: is this number 1, 2, 3, 5, 5, 8, 4 divisible by 8? First we divide by 1000, draw a line to the left of 3 digits, and first divide by 1000. Okay, and so that would mean draw a line here to 3 digits, toss out the left part, which is quotient, and 584 is remainder. Remainder is 584. Now we divide 584 by 200. What's the remainder is? First 100 1 divided by 100, 84 is the remainder, and then we divide the 5 by 2. Remainder is 1. That's right here. So remainder is 184. Or we subtract our 200 and 200 twice from 584. I got 184 left. Okay, next we'll divide by this remainder by 80. So if we take out 44 times, you get 24 left. So I first divide by 10. 4 is the rightmost digit of remainder, and divide 18 by 4. Another 2 ways remainder here, 24. Okay, 24 is in this list. 24 is divisible by 8 and also is in this list: 0, 8, 16, 24, 32. So this number is divisible by 8. Let's continue. So this number is divisible by 8. Okay. Similarly, we can determine successive divisors for divisibility by 16, 32, and 64. Let us do some exercises. Are these numbers divisible by 4 and 8? R by 8. So first number is 750, this is odd. And theta, you would say it's not even in the code. So we could just say toss it out. Now it's not divisible. Now look at other number 8916228, 82136, 65786, 986038, and some more. Let's look the references. Uh, Main reference for this video is this Vedic Maths ebooks.com/memory mentor underscore maths underscore tips.pdf, and I get most of the ideas for the video from this write-up here, but I rarely use the same approach as this write-up does. Okay? And this write-up contains many more topics like multiplication by 11, multiplication by 12, square of numbers ending in 5, uh, adding and subtracting times, and some more. Okay, so do go ahead and use this PDF booklet here for further topics for shortcuts and tips. Okay, let's continue here. And these are my usual references for Vedic math. Uh, it's for most folks this basic teacher's manual, which is a Vedic math teacher's manual, elementary level, by Ken Williams, which you can get from vedicmaths.org, and PDF form of the book is free. This book is good enough for most of the folks, beginner folks, okay? And for the serious folks in Vedic math, researchers and teachers, this is the main reference. Vedic Mathematics by Bharati Krishna Tisaji. That's the primary reference on the Vedic math. And Discovery Vedic Math is by Ken Williams, is by most complete, authoritative, and consistent notation book. But it organizes topics by sutras and not by topics. Okay? And the Vedic Math for Schools in 3 volumes by James T. Glover is a decent book, well readable, and covers most of the topics. It's probably as complete as any other book except the Kenny Williams Arthur Studies book. So that is it. So you can go look for this tips write-up ebook, or you can look up teacher's manual elementary level, or Bharti Kshatriya Studies book. For tips, this is the only topic for the tips. Okay, only reference is this thing, and it has covered numerous more topics than I covered in the video. Okay, and but for Vedic math, this is the ultimate reference. Tristaji's book, most complete. His authoritative reference to Ken Williams' Discovery Vedic Math, and Vedic Math for Schools is by James T. Glover, is the reference for is well readable and cover most of the topics. Uh, had numerous exercises and also does geometry also. Okay, that's it.